So good morning, everyone. Welcome to Conversations for the Future. Today we have an expert speaker lineup for you. Our first two speakers will each present for about 20 minutes, and we'll have a question and answer session directly after each presentation. You may ask a question by raising your virtual hand in the Q&A segment or by putting your question in the chat at any time. Foundation for the Future is a nonprofit organization dedicated to advancing space infrastructure for the good of America and for the good of humanity. We depend on your membership to fund our initiative. If you're not a member, please check out our membership webpage. We have many different membership tiers to accommodate any budget. If you cannot become a member and prefer to donate to Foundation for the Future instead, you can donate on our webpage. We will add these links to the chat so that you can learn more. Thank you for your much valued support. And now to our presentations. Our first speaker is Stephen A. Daire. Stephen is a Northrop Grumman Deputy Element Lead, Protean Industries CEO, Comfirst Co-Chair, Explorers Club member, Scientist Astronaut Candidate, and Scientific Cave Diver. For the past 5 years, he has developed ISO and IAIA satellite servicing standards. He has conducted laser scanning experiments with the Canadian Space Agency on debris inspection and survey. He's a former National Geographic Society shipwreck co-director. He has led an Explorers Club expedition on microplastic laser surveys and identified hotspots via submersible at below 2,000 feet. His 9 years of experience uses XR, AI, robotics, remote sensing, and 3D printing in exploration and sustainability. Welcome, Stephen.
Thank you very much, Rebecca. Good morning, everyone. When we were asked to do this presentation last week, we were elated. Full transparency, I'm a systems engineer. I do a little bit of project management, so the workforce stuff is, kind of extrapolating out from the things that are being built and where we kind of see that future taking us. I developed this with our design and engineering advisor, Ricardo Leon Jimenez. He is former Lockheed Martin, former NASA, and now runs his own design company, Pactica. So what are we talking about today? We're going to be digging into teleworking. Coming out of the forefront of COVID, teleworking was the way the economy kind of had the quick pivot to be able to maintain operations and continue the engine running. Now that we're going out of lockdown era, more workers are requesting that kind of work as we leave so they can maintain their work-life balance. Companies are aiming to stay competitive and sync with the new space economy, should really be utilizing telework as a metric of success. The volume and breadth of telework jobs will only increase as NASA Artemis mission and programs progress and extend our reach onto the moon and into deep space. Teleworking has the capacity to expand the traditional aerospace industrial workforce. Not only can it include individuals with disabilities that could not formally become astronauts, it can also include other trade skills and research domains as hands-on operators that have been excluded in the past. The new space economy, telework, is an environmentally friendly solution that we desperately require to combat climate change as we continue to grow this industry and pivot into a green economy. It benefits employees by allowing for flexibility for work-life balance and management. It eliminates the need for relocation for jobs, and it provides the potential for high-value, long-term career growth with job satisfaction in the face of market destabilization due to AI. Telework jobs in space will relate to space debris removal, that will assist in saving on mission planning and spacecraft design by de-risking the space environment. They will promote environmentally sustainable jobs benefiting the UN Sustainable Development Goals with reduction to poverty, good health and well-being, quality education, decent work, and economic growth, industrial innovation and infrastructure, sustainable cities and communities, as well as climate action and partnership goals. This area of workforce development will also provide opportunities for skills and specialties related to future asteroid and comet capture missions for the future of space mining. As you can see, the video playing on the side from NASA highlights the extent of the space debris problem and the need for teleworking operators to be able to begin addressing this. Telework jobs in the satellite servicing industry will also benefit mission planning and spacecraft design. These jobs will also be environmentally friendly and sustainable by reducing waste, improving recycling, and dealing with debris clutter and mitigation for long-term mission planning in space. Telework satellite servicing will also promote development for innovative missions and workforce developments that can eventually move on to space stations and spacecraft that do not exist currently. Telework benefits for moon bases and space habitats will provide the infrastructure building and services required by astronauts to afford safe and successful long-term missions on the moon. Benefits will also include developments in careers for mining, surveying, shipping, production, and resource processing on the moon, which are currently required to be able to begin setting the foundation for a long-term persistent human presence. Ultimately, the development of the industrial base and workforce will impact the space economy in beneficial ways. The benefits for telework will lower overall business costs, reduce employee turnover in the aerospace industry, bring new capacities and perspectives towards mission accomplishment. Telework will also provide opportunity for long-term recession-resistant economic scaling and growth across multiple market sectors. It also enhances recruitment and retention of high-quality, diverse workforces. Ultimately, this will reduce emergency and stress loading within the space economy related to mission planning and uncertainty. By 2040, the space economy is projected to reach $1 trillion as analyzed by Morgan Stanley, with the breakdown between internet, consumer TV, ground equipment, consumer broadband, government utilities, and other market expansion areas. This provides a litmus test of what future careers within the space industry will look like within the telework domain and in terms of ground astronautic presence on the moon in deep space. The in-space assembly and manufacturing, or ISAM, workforce outlook ranges from satellite value chains, human exploration, research and development in science, and other areas. These are predictable and demand will most definitely increase from hundreds of millions to billions per year, which will directly input into the development of the telework new space economy and the possible careers it provides. This estimate is limited only to in-space servicing, assembly, and manufacturing, and does not consider the other myriad of jobs that could potentially grow from the market related to operations on the lunar surface required by the Artemis missions. The government will be the initial primary consumer contracting out to private firms, with the commercial sector following as the second main area of growth. The in-space servicing, assembly, and manufacturing supply chain is already starting to diversify into 5 tiers related to systems, subsystems, assemblies, subassemblies, components, and materials, which will relate to the job market growth on Earth to deploy these systems in space, and then the breakdown of telework and other functions across those 5 tiers to maintain those systems. Potential remote operator jobs for telework might include tug operations, fuel management operators, mechanical repair and intervention operators, electrical repair and intervention operators, as well as drone deployment operators, which spans between technical, white collar, and trade craft or blue collar jobs. Telework positions in the workforce will expand from low Earth orbit to cislunar and lunar surface operations and continue on to cis-Martian and Martian surface operations, as we have already seen progress through the Artemis program development, and will begin to move outside of the government stakeholder frame into the commercial, astronautic, and aerospace sectors. Robotics will be a prominent feature of the developing new space economy, telework industrial base, with a permanent robotic presence being the key to long-term success on the moon. Teleoperated robotic systems will lead the exploration missions that will then provide foundations for human development. Teleoperated robotics can tolerate the extreme environments which humans require information on to develop new systems for robotic and human survival. Teleoperated robotics can handle a wide range of tools and tasks necessary for developing the initial infrastructure for human survival on the moon and in deep space. Remote operators will be the bulk of the new space economy teleworkforce and will have the majority of tasks supervising, operating, and upkeeping their robotic counterparts throughout their mission lifecycle, and utilizing them in new and creative ways to be able to conduct scientific and exploration operations on the moon. Human factors will also play a critical role within the development of the telework new space economy. Human-machine interactions will be critical in terms of development of this workforce due to the lack of situational awareness on the moon for teleoperated robotic systems. The need for real-time information, the ability for dynamic adoption, and the capacity to multitask and manage multiple robots simultaneously will need to be a key within the workforce. This will relate to real-time contextual information, adaptive dynamic conditions that need to be addressed on the fly, multitasking at various points of the mission, and management of multiple robots simultaneously. The concept of operations will likely break down as assignments divided between robotic operators, dispatch systems, and overall supply chain or clearinghouse management architectures stemming from the Artemis program. Handover of the robot and the mission to the operator will include guidance, navigation, control, and manipulation from the dispatch system. Teleoperation will then be conducted in real time with the support of multiple telecommunication networks in the deep space network. We thank you for our presentation today. And we are very happy that Rebecca and April reached out to us to come and present on this topic.
Great job, Stephen. That was really fantastic. You know, and you were kind of making me think, is this why Tesla, Elon Musk is making this army of robots, is so that Mars, is that the true civilization of Mars, is going to be all robotic?
I mean, initially, and then humans will come as the second wave. That's a great question. If you build it, they will come, and hopefully the robots will build it for us, and we can find a nice little middle ground to be able to work with them effectively.
That's really, really, it's like, I know we say this all the time, but it's like the future is here.
Oh yeah, when Ricardo and I were putting this presentation together, we were kind of future planning or strategically forecasting, what is gonna look like what and who's gonna have what job, what are those gonna relate to, and even articulating it down to those levels. You'll need electricians, you'll need plumbers, you'll need mechanics. Everyone that you have within a 20-mile radius of you, in your town, in your community, all the support services and products and businesses are going to be required in this to be able to develop these systems, keep them running, and have them be utilized and repaired on the moon to build up the workforce, but also to build up the economy incrementally. So, it was hard to put a line on, who is not going to be needed. We didn't even get to touch in on the on the requirements of educators within this system to be able to train people how to operate these robots effectively, what the mission planners will be doing. So yeah, this is just the drop in the bucket of what we need to be preparing for.
And it makes me think about how, in days past, people have told us that, AI and robotics, yes, it's going to take a lot of jobs. Like a lot of people will lose the job they're doing because robotics and AI will take that place. However, many more jobs will open up that we don't even understand yet, that we don't even know about yet. And this makes me think this seems almost like a whole new field that's going to require a lot of new workforce entrants. And
Exactly that. You're spot on. It's hard to even fathom. So in some ways you're going to have a new cycling of careers. Things that have been foundational for the past 100 years are going to now transition into the new the new paradigm. So it is a little startling, and there's got to be backup in legislation to make sure that there's a transition funnel for those people to move into those new areas of work. Um, and so long as something like that occurs, it's easy to build these systems, but the thing you don't know about Chat GTP on one side or the other, like we were talking about before, is it constantly needs updates, fixes, and repairs. And uh, those are the things we don't always acknowledge in the day to day. But you could say the horse and buggy went extinct, but now we have cars, and instead of farmhands taking care of the horses, you have fleets of mechanics and production engineers and everyone building the cars or keeping them moving. So yeah, you've got to kind of also expect that wave of change and make sure that the workforce is, prepared and set to be able to take that in stride so that everyone is, not left out of work.
that, and I can see, by the way, anyone who wishes to answer a question or ask a question, please raise your virtual hand now or put your question in the chat for Stephen, and we'll bring it up. Stephen, this makes me think that this is going to be a new wave in tech schools, in colleges, universities, even from high school. And that's really what Foundation for the Future, that's what we do, is we work with Congress to get that workforce going so that we don't have this gap once once the technology is up and functioning. Right now, a lot of the technology is in beta. Once the technology is up and running and we're actually on the moon, we're on Mars, we're in cislunar orbit, we're going out to space, we're going to the asteroids, we can't wait another 5 years for people to learn the skills to get into the workforce. So are you seeing any of this in schools yet? The remote operating field of study? Is it an actual field of study right now, or a certification, or do you have to learn it in-house?
That's a great question. So as a parallel, I'm doing my second master's in systems engineering. One of our advisors, Heidi Hammerstein, was environmental engineer and worked for Gulfstream and is now doing HLS work with NASA. She became a systems engineer by doing the work over the past 20 years. Systems engineering was not a formal area of study when she went to school. When I told her what I was applying for, she was like, "That's an actual degree now." So, the things are starting to escalate more quickly in terms of operators. A lot of it is, learn it as you go. And there are some formalized FAA programs for drone operators, but it doesn't extend beyond that, except for on-the-job training. So yeah, that's going to need to be a big development within the operations side of aerospace engineering and mission planning and management, as well as the technical school trade-offs and curriculum development. So right now, that does not exist, and it is definitely required. Finding out who will be the champion of that, either in the commercial side of things or on the government side of things, or time will tell. But yeah, waiting 5 years is not the answer. You've already got a couple of companies trying to land their systems on the moon for CLPS with commercial lunar payload services with NASA, and those are very much in-house right now. But as you start seeing that become more ubiquitous, you're going to need to have that as a very large workforce for the market to be able to rely upon.
That is fascinating. And do you think that the younger generation, as they grow up playing video games and gaming, do you think that that might set them up for future careers in remote operations?
Yeah, I would be surprised if it doesn't. I know it's helped me with some of my stuff, like piloting underwater robots and aerial vehicles for surveying and 3D scanning. Even then, I've taught one or two groups of students how to do it, and I hand them the controller, and they're better than me. So there's definitely a massive learning curve, and that neuroplasticity of the younger kids getting their hands on a DJI or a different robotic controller and then just flying it, and they're going to have a much easier time picking it up and moving with it faster. And then it's relying on us to make sure that they're getting their hands on it as quickly as possible and learning how to operate these things. The moon and Mars are going to be wholly different environments. I mean, with Mars, it's an atmosphere and no atmosphere on the moon. Um, a lot of testing and research will have to develop for those kids to get to those points, and then, they'll be starting to set up the next generation after them in all the lessons learned and ways to best operate. So it's exciting, and laying the foundational stones now is going to be critical.
That's really interesting, especially the part that you said about the neuroplasticity. Like it's almost like kids are growing up able to connect better with the machines, with robotics, and for so long we were like, get that out of his hands! Don't let kids play video games. It's bad for them. They need to get out and socialize. And actually, this is ironically, this may be setting our children up for future jobs for
Yeah, exactly that, and that's one thing that's not deeply discussed is a lot of the military grade robotic systems are all operated through a PlayStation or Xbox style controller. Um, so if you extend that to what we might be operating on the moon, I mean, give it 5 to 10 years, it could all be virtual reality. So you slip on the Oculus Rift or the HTC Vive, you have the controllers in your hand to let alone move the robot and direct the cameras, but the handheld joysticks to be able to operate robotic arms and things like that. Uh, and some of that work is starting to be developed in virtual reality simulators, but kind of planning for that shift and maybe a mix of the two components, or multiple people operating different parts of a robot at the same time, kind of like NASA does now. Uh, it really does look like the way things are going to break down, and their generation is already uh, going through the motions and learning all of that and playing those video games and getting those very hand-eye coordinated skills that are going to be critical to not lose multi-million-dollar machines on the moon and conduct these operations. So yeah, the gamers and the engineers and the tradesmen are going to all have a really interesting time of it as they move forward.
I agree. And do you see this becoming something that, say, at middle schools and high schools, it could be instead of like welding club or Spanish club, they're doing robotics club, and probably they're already doing this. Do you see that happening more and more where teachers, even though they may not have the curriculum yet in their main curriculum, but they could, however, do extracurriculars to help getting these kids ready for the future workforce? How do you see these needs fitting into our current educational system?
Good question. So two halves to it. I had friends that went to the vocational school in our county. And I had friends so it started just as I was getting into my senior year of high school. A group called First Robotics has started doing that within high schools, and they have a national competition where each school will go and build a robot and test it out, and they're given a mission to complete or a problem to solve, and they'll go through the levels of building the robot, coding the robot, and testing it to get to that point. So that's on the non-vocational side of things. On the vocational side of school, those students are learning how to uh, put together circuits, weld circuits. I don't know if vocational schools have started incorporating machine learning or coding or things like that. But when you start layering those things together, they need to happen in tandem for robotics, especially. You can't have the one without the other. But a FIRST Robotics program that spans both of those. I don't know if FIRST Robotics has moved into the vocational schools, But if you bring those teams together in a county by county paradigm, you'll have the kids learning how to build circuits right next to the kids learning how to do computer aided drafting and design, and then they can pull those together. There are a few undergraduate, graduate, and PhD level robotics programs coming out now. University of Michigan, I just met an undergrad who's moving into a master's to PhD program doing that. There are one or two other schools. It's kind of a niche path from there. Uh, so it is not formalized at the levels in younger, K through 8, maybe 10 to maybe grade 10 is where it starts to really proliferate, and getting it down lower from there is going to be key. I don't know how many, middle schools and elementary schools have things like Lego robotics or Lego robots in their classrooms, but it would be interesting to see how quickly kids those ages pick it up.
Wow, that is so exciting. And I have one final question to ask for you, and then we'll thank you for being here today. It truly was a great presentation. I learned a lot. I know that our listeners here on live on LinkedIn learned a lot, and our in-house listeners here also. Okay, so my last question to you is Iron Man spacesuits. How soon till we get to be enclosed by an AI robot that we can just be out there working on the moon, and we're kind of meshing the two together, and we just walk around with our Iron Man spacesuits? How soon how long till we get that?
That's a really good question. So I know NASA is already working on an AI integrated HUD for the new spacesuits. There is a group out of Austria that works with ESA that has an integrated HUD that does not utilize AI. And MIT is working on a suit that is, can be worn on the day-to-day basis. I don't know if they've integrated AI as a capacity within that yet. Um, Something like Iron Man, maybe 5 to 10 years out, depending on the level of complexity and awesomeness that you require of your suit. Maybe it'll be bespoke. You want a jetpack? Okay, you got it. You don't need a jetpack? Okay, cool.
Yes, exactly.
It probably a healthy 10 years, but it's hard to judge innovation and how quickly people are moving forward. Spacesuits are a bit of a problem child for development because you're trying to do two conflicting requirements at the same time. So I would say probably 10 years. And hopefully I'm wrong and it's done sooner.
Well, as long as it's coming, that's good news for us. Stephen, thank you so much for presenting today, and thank you to Ricardo for putting together the design on your presentation. It's a beautiful presentation. I always admire Ricardo's work. Ricardo's listening here with us today, and thank you, Stephen. Good luck to you and all that you're doing, and please stick around if you have time. Ask some questions. Our next speaker is coming up. So thank you for being with us, Stephen.